Everyone, Mr. Burke here. So I'm going to be recording, going over the practice test that I posted on Canvas on Thursday night after I got home, and I did have surgery yesterday, so um, probably avoid being on camera because it will kind of show sometimes. Anyway, let's share. And yeah, the extraction of the tooth went successfully, so hopefully in the next 4 to 5 months, I will have a new tooth implanted in there. That was 32 and a half years after my incident causing my jaw to break all the way through. Not fun. Okay, so you'll follow along with the practice test here. This is what I downloaded for everyone online. So I'm going to be doing the questions on the paper here, where I have ample room to show the work. So in the first question, it wants us to find the value of, for question one, the value of f of -6 for the function when f of x equals 9 minus 3x squared. Now, you'll see that in the problem, they don't put the parenthesis there. But if I put a -6 here, I'm going to put a -6 here. So if I have f of -6 equals 9 times 3, 9 minus 3 times -6 squared. Now, if you have a calculator, most calculators will kind of do this for you automatically if you do this. Otherwise, if you have a less sophisticated calculator, you may need to be cautious about how you do order of operations. So first thing, you want to take care of the exponents. So this would be 9 minus 3, and then -6 squared is going to be positive 36. -3 times 36, we have to do the multiplication first. That's going to be -108. And then 9 minus 108 will give me -99 for the answer. And I want to say, I think when you got this, you also got the answer key. So I hope everyone did. Also note that we actually have the test in hand, that the test is going to be several pages long, allowing for plenty of room to show all of your work. So it's not like you're going to have to do work on a scrap piece of paper. It'll all be turned in and graded as such. Okay, question 2. And this one, it's asking us if we're given the function f of x equals 5x squared minus 2x, find the value when we put in t plus 2. So here, when I replace this x with t plus 2, I'm going to replace this with t plus 2, and I'm going to replace this with t plus 2. So we have f of t plus 2 equals 5 times t plus 2 squared minus 2 times t plus 2. Okay, so be careful of the algebra with a question like this. What I'm going to go ahead and do first is I'm going to square what t plus 2 squared is. So I have t plus 2 squared. Well, that's equal to t plus 2 times t plus 2. And I'm going to FOIL that. So I'm going to do my first here. That's going to give me t squared. I'm going to do my outer here. T times 2, that'll be 2t. I'm going to do my inner, that's also going to be 2t. And then when I do my last, 2 times 2 will give me 4, that's plus 4. 2t plus 2t, that's going to give me plus 4t. So the quantity of t plus 2 squared equals t squared plus 4t plus 4. So I'm going to replace this quantity here with 5 times t squared plus 4t plus 4. And then I'll continue to write minus 2 times t plus 2. So to continue evaluating this, I need to distribute 5 through this here, and I need to distribute -2 through here. This will give me 5t squared plus 20t plus 20. And then it's going to be minus 2t. -2 times t is minus 2t. -2 times positive 2 going to be minus 4. And now at this point, I can work to combine terms that are like each other. So notice here I have 5t squared. There's no other term that contains a t squared, so I'm going to write 5t squared plus 20t minus 2t. 20 minus 2, that'll be plus 18t. t, and then plus 20 minus 4 ought to give me plus 16. So f of t plus 2 is equal to 5t squared plus 18t plus 16. Okay. Now, notice here I'm being very deliberate about showing all the work because this is review and I want to make sure not to skip any steps. You know, if you're able to kind of do this mentally and you can get from this to this, I'm okay with that. But the more work you show, the more partial credit you're likely to earn. You know, in the instance, you may get a question wrong for some reason. So I would encourage you to show as much work as possible when you can. Going on to question 3. In questions 3 and 4, they're asking you to find the domain. So we're going to take a look at 3 and 4 on each side of the page here. In the case where we have f of x equals x over x plus, x minus 2, what is likely to restrict the domain is this fraction. And we're going to go ahead and set the denominator equal to 0 so we can find what value x cannot be. What minus 2 equals 0? That should be 2. So let's set x minus 2 equals 0. And if I add 2 to both sides, I see here that when x equals 2, that's going to make the denominator 0. So 2 is the one number I'm going to exclude from the domain. So I'm going to go ahead and write this as negative infinity to 2. Now, you don't put the union symbol. The book didn't seem to make a big fuss about that. But I would prefer you have that if you could. That's how I would write the domain of the function here. And there is an interval notation. Let's examine question 4. And we have here for this function, f of x equals radical 3 minus x. Now, in this case, we can't let any negatives under the radical. We can have a 0, but we can't have a negative. So as long as this stays either 0 or higher, we're good. So what I'm going to do with this one is I'm going to take 3 minus x, and I'm going to set that to be greater than or equal to 0. And if I do that, I'm just going to add x to both sides. Now, I'll be careful of this one. If I do this, I have 3 is greater than or equal to x. If I flip this around, 3 is greater than or equal to x, watch what I'm going to do. I'm going to switch this and make this x. I'm going to put the 3 over here and see how this is pointing at the x. This needs to remain pointing at the x. So I'm going to say x has to be less than or equal to 3 in order for this to work properly. So if x is less than or equal to 3, we can say that on a number line, it's going to look like this. Here's 3. Okay. We can include 3, so I'm going to put a bracket here, and I'm going to put an arrow pointing to the left on a number line where 3 is. And then in interval notation, this is going to be negative infinity to 3 with a bracket, because again, if x is 3, 3 minus 3 is 0, and 3 is perfectly acceptable. But if we have anything greater than 3, for example, like if we have 10, 3 minus 10 will be negative 7. We can't do that. We can't obtain a negative under a radical and have that work. One of the things you'll often hear me saying, Claire, are there any questions? And I often want to say that when I'm doing videos here, but when there's no one on the other side to ask the questions, I have to kind of bear in mind to forego that practice and save that for class. Here we go. So in the question, we're asked to find, in question 5, we're asked to find the slope of the y-intercept of the graph of the equation. Now, hopefully for most people, this is going to be a fairly straightforward question because this is an equation that is written in slope-intercept form. So in other words, it's written in the form of y equals mx plus b, where m is equal to the slope, and then b is equal to the y-intercept. And if we're looking for this information and the equation is not written in this way, we'll usually ask students to write it in this way. So from this information, we can include that m, that's going to equal, equal negative 4, and then that b is equal to positive 6. Okay, so this is the information on the test that you want to give. You want to find that the slope is equal to -4 and that b is equal to +6 for the y-intercept. In question 6, we're asked to find the slope of the line containing the given points. So in this question here, we're provided with 2 points, 6, 1, and then 6, -4. Well, for this one, I'm going to go ahead and label these 2 points, x1, y1, then x2, y2. And I'm going to go ahead, I'm going to put this into the slope formula. Now, if I put these in, y2 is going to equal -4, y1 is going to equal 1. We have x2 is equal to 6, x1 is equal to 6. Now you notice on top here, -4 minus 1, that gives us -5. But 6 minus 6 is going to give us 0. And 5 divided by 0, that's going to give us a slope, which is undefined. So in this particular question, our slope is going to be an undefined slope. So if we had a 0 on top, we would say the slope is equal to 0. But because we have a 0 on the bottom and we can't divide by 0, we say that that is undefined. Let's go and take a look at number 7. It says write an equation of the line with the indicated slope and y-intercept. So if you know the form of the line in slope-intercept form, y equals the slope times x plus b. What they're looking for you to do is strange. This is like the same answers as we got in number, it's like the same as number 5. Very unusual. So if I put everything in for m and b, I will get y equals -4x plus 6. I had to look at that twice just to be sure that was correct, and in fact it is. Okay, so that is question 7. The next 2 points I'm going to, the next 2 questions I'm going to do directly on the test paper. It'll be especially helpful to have the graph for this to show how this is done. 8, it says use the graph to find the slope-intercept form of the equation of the line. So a couple ways that this could be done. I'll use the more traditional way. Okay, first off, we can see that if we look carefully, this line appears to cross at 3. So we can see from this graph that b, that's going to equal 3. Okay, so if you know what b is, you can actually find 2 points and get the slope formula. Or if you want to, you can actually use one of the points that's on the graph. Like we could take the point, for example, here. This is a point 3, 0. And we can put it into the equation y equals mx plus b. And then we can just get the value of m. So this is a strategy that you can use as long as you can clearly see where the line is crossing the y-axis. So, excuse me. To do this, I know this is going to be y, so that's 0 equals m times 3 plus, that's going to be 3. So if 0 equals, it's going to be 0 equals 3m plus 3. So I'm trying to solve for 3. I'm going to subtract 3 now. So I have -3 equals 3m. I'm going to just write this up here, not change anything, just so I can kind of complete my work here. Now, if I divide both sides by 3, I'm going to get m is equal to -1. And finally, if I'm going to write the equation of the line and slope-intercept form, I'd write it as y equals, I could write it as -1, I would just write it as -x plus 3, and I'd have the equation of the line. If you put a 1 here, that would be perfectly okay. It's just not the custom to put the 1 as it is not needed. Let's go ahead and take a look at question 9. So let's find the slope of the line containing these given points here. So we're going to go ahead and use the slope formula on this one again. Here's my x1, y1, my x2, y2. And in the previous problem we wrote the slope formula, so I'm not going to go write it again. This is going to be 8, because this is y2, y1 is -4. And this is where having the parentheses for each of the values comes in handy. This is the negative associated with the formula. This is the negative that comes from a point. X2 is going to be -5, and the next one's going to be 2. Well, let's see what we get here. 8 minus -4, well, minus and negative is like plus. So 8 plus 4, that will equal 12. And then -5 minus 2, that's going to be -7. So I'd write this slope as -12/7. And so for this one here, since we're giving the slope of the line, we want to say that m is equal to -12/7. The one thing that's considered not good form is to leave the negative in the answer. If you want to leave the negative on top or in the center of the fraction, that's fine, but it's not considered good form to leave it at the bottom. So you can write the slope as -12/7. Okay. This is a question. A few of these questions I'll go ahead and do on here too, not all of them. I think number 11 I'll probably do on a separate piece of paper. It says here, graph the function 2 to the negative x minus 2. Now, this one's a little tricky. This one's a little tricky because the exponent is negative. It's far easier to work with positive exponents than it is to work with negative ones. So if you should encounter a question that has a negative exponent, instead of like working with 0, 1, and 2, you are probably going to want to work with 0, -1, and -2. And let's see what happens when we do so. So I'm going to create table. Here's 0. Here's 2 to the minus x minus 2. And then here are going to be my f of x values. All right, so first I'm going to start, these are my x values here. I'm going to start with 0. So that's going to be 2. Now, 2 to the 0 is just going to be 0 because there's no such thing. You can put the negative if you want, but it won't have any impact. Minus 2. Well, evaluate below. 2 to the 0 equals 1. That's going to be 1 minus 2. That'll equal -1. So the first point we're going to have is going to be, let's put the point here. Kind of bringing everything together, 0, -1. So that's going to be our first point here. The next one, let's go and put -1. So now we're going to have 2 to the -1 minus 2. Well, 2 to the -1 minus -1, that's going to give me 2 to the first minus 2. Well, 2 to the first is equal to 2, and then 2 minus 2, that's going to give me 0. So this is going to be the point -1, 0. So that's going to be a point that looks like this. Let's go ahead and get one more, and I think you'll get the general idea of what the graph is probably going to look like. And again, you don't have to draw it perfect, but if you give me 3 points, that will be fine. Let's go with -2 then. That'll be 2 minus -2 minus 2 minus the negative is going to be 2 squared minus 2. 4 minus 2, that'll give me 2. So my next point is going to be -2 and then 2. So here are my points. So I'm going to go -2 and then 2. So you kind of remember what the graph of exponential functions looks like. And then it's going to go up quick from here, and then from here it's going to go kind of to the slowly to the side. But if you give me the graph of 3 points and give me the general shape after that, I'm going to be perfectly happy with the graph that you provide. Don't have to give me points, but they're probably preferred. Okay. All right. Hope that makes sense. And we did some of those in class. Although this is the first one with a negative, so just be ready for something similar in that regard. So hopefully everyone watches this. I'll come back to number 12, or sorry, number 11 in just a moment when I have some room. It says here, use the graph to evaluate the function f of x at the indicated value y. It wants the value of f of 2. So if I go where x is equal to 2, I see f of x, this appears to be -4. So we could say that f of 2 equals -4 based on what I see here. Okay. Let's take a look at equation number 13. It says e to the -0.7t equals 0.005. Okay, so what I'm going to do now is I'm going to try to get t by itself here. So in order to do that, let me go and take the ln of both sides. So I'm going to take the ln of e to the -0.07 t equals equals e to the 0.05. Now, now I can bring this exponent down. This is a step that's, if you look at the bulk, it'll skip it a lot. I'm going to bring the exponent down, so it's going to be negative 0.07 t times the ln of e equals e to the 0.05. Well, hopefully everyone remembers that the ln of e that equals 1. So I'm going to write this as negative 0.07 to the t equals e to the 0.05. And now, if I divide both sides by negative 0.07, I should have t is going to equal e to 0.05 divided by negative 0.07. And all this should be doable on your calculator. And for question 13, if you write this to 4 decimal places as requested, so make sure to follow this. If you don't follow the decimal places, it's a point, like out of 5. So just be careful. This is all going to be equal to 42.7962. And that's going to be the value of t in the function for question 13. What I'm going to do next is I'm going to go ahead and do the question number 11. That I'm going to do on a separate sheet of paper. And it says here that we want to find the break-even point for this. So if we're looking at the break-even point for cost and revenue, you recall we did a couple examples in class. So what we're going to do is we're going to set these two equations equal to each other and then solve for x. So the break-even point is where cost is going to equal revenue. That being the case, means that cost is equal to 15x plus 12,000. And then revenue is equal to 18x minus 6,000. Now, probably what I usually like to do is if I can keep the x positive, it will. So I'm going to go ahead and I'm going to subtract 15x from both sides. Now, you don't have to do it this way. If you want to, like, maybe subtract 18x to the other side to keep the x to the left and then bring the 12,000 over. That's perfectly fine. This is just my method. So this is going to be 12,000 equals 3x minus 6,000. So if I add 6,000 now, then I'm going to have 18,000 equals 3x. And remember that x is the number of units this company has to sell in order to break even on something, on, you know, how much money they're taking, they're expending to reduce this. So if I divide both sides by 3, we're going to get x. 18,000 divided by 3 is going to equal 6,000. So you have to sell 6,000 of these units in order for the company to break even. Okay, so that's going to be the answer to question 11. Oops, I'm going to move that up a little bit. So that's 6,000 there. So 6,000 equals x. And by the way, while you're home for the weekend, if you have any questions you want to follow up on, don't be afraid to shoot me a message. You let me know what those may be. Okay, we have a few others with graphs here. We'll definitely utilize the picture here to kind of pick these apart. All right, so let's take a look at this. Use the graph to evaluate the indicated limit and function value or state that it does not exist. Okay, so in these two questions, we're asked to find the limit as this approaches 0 from the negative side, so the negative being the left, and the limit of x as it approaches it from the positive side, that being the right. So if you want the limit as x approaches 0 from the negative side of the function of f of x, we see that this function here is approaching 5. If we want the limit as x approaches 0 from the positive side of f of x, well, we see the function to the left here, this is approaching, now it doesn't get to it, but it's approaching -1. If you were asked as a third question, what the limit as x approaches 0 is for this function, because it does not approach the same value from both directions, then you would say it does not exist. Just as a little reminder, should you get a little question like that. Okay. Hope that is clear to everybody. Let's take a look at this one. It says here in question 18, we're going to go to these questions here in just a moment. I just want to make sure to do this on paper. The graph of y equals f of x is shown. Use the graph to answer the question. Is f continuous at x equals 2? So we're looking right here, okay? And does the graph appear to be continuous at 18? Absolutely, yes it does. So you would just answer yes to the question, and that is all they're looking for. So it either is continuous or is not continuous. Let's go ahead and look at questions 15 through 17 on the paper. All right, oops, bring this up here. So in question 15, it wants us to find the limit if in fact it exists. So we have to find the limit for x approaches -1 for 6x plus 5 over 5x minus 6. Now, some of you may be tempted to look at this and think maybe there is something to factor. Generally speaking, as long as you're not going to get a 0 down here, which you're definitely not going to in this case, you can go ahead and just put the value in. So let's go ahead and do that. So since we're just going to go ahead and sub this in, we don't need to write the limit again. It's going to be 6 times -1 plus 5 over 5 times -1 minus 6. So 6 times -1 will be -6 plus 5. That'd be -1. 5 times -1 will be -5 minus 6. That'll be -11. But you don't want to keep that as -1 over -11 because a negative divided by negative is positive. So we're just going to go ahead and write this as 1 over 11. And that's the limit of the function as x approaches -1. Notice here it's not approaching from a particular side, so we're fine there. Let's go ahead and take a look at 16. So we'll want the limit as x approaches 3 of x plus 3 over x squared minus 3x. So in this question here, what we'll want to do is we're going to want to factor this a little bit. And if we let's see if we factor this, will something change? It's a good question. I don't. Oh no, sorry. This is x minus 3. My apologies. Yeah, my apologies on this one. All right, so if x approaches 3 here. So what I'll do is if we factor this, then I'm going to write this as the limit as x approaches 3. This is going to be looking at this. If I factor the bottom, I'm going to get x minus 3 here. This is going to give me x times x minus 3 here. I'm looking at the solution, and the solution has it as non-existing. But I feel like if I reduce top and bottom, I'm going to get the limit as x approaches 3 of 1 over x. And this should give me 1 over 3. So I may have a chance to kind of take a look at that question again. I'm not sure about that answer. Once in a while, I do get a discrepancy with this. So I would not worry about a question like this. If I see it come up on the test, I would be sure to kind of, I would give credit for that, but I will take a look to see, to avoid a question like that, because that shouldn't be something that comes up where like a limit doesn't exist where I've taught you otherwise. Let's go and take a look at number 17. Let's see. We have, we want the limit, and I'm just going to go right in the question, as x approaches -2 of x squared minus 3x minus 10 divided by x plus 2. Well, limit definitely exists for this one. That's not in dispute. So, what I would do, if you see x plus 2 down here, it's very likely. Oh, sorry. Let me put this down here again. The limit, because I want to make sure to keep writing the limit. The limit as x approaches -2. If I have x plus 2 here, you can be sure that x plus 2 is going to be one of the factors up here. And the other factor is going to be, well, 2 times what will give me -10? 2 times -5. So this is going to be x minus 5. And that does in fact work. If I reduce x plus 2, that's going to give me the limit as x approaches -2. Yeah, see, I do this here. It corresponds with the answer I have in the solution manual, so I'm not sure why they say this one doesn't exist. I would just stick with this method, I think, for 16, as I've shown you. And this is going to be x minus 5. And once I evaluate this, then I'm going to have -2 minus 5. And it's going to equal -7. So that's the limit of question 17. All right, we have 2 more questions on the last page. Yeah, here we go. And actually, these 2 I'm just going to complete in here since I have ample space here. And now it asks the question, is f continuous at x equals -1? And for this one, it is not continuous, okay? Because you would have to have, for this one, for example, we can find that f of, if you watch this, how we did this in class before, we had f of -1, that is going to equal, it looks like it's going to equal then -1, looks about to be like -2, whatever. I think it's close to -2, I think, whatever that is. But if we take a look at the limit as x approaches -1 from the negative side, we can see the limit of the function. We can see it's approaching the value of 3. And by the way, this is supposed to be -2. So from the left, it is approaching 3. On the right, it goes to 2. These have to be the same in order for this to be continuous. So the answer to this is no. It is not continuous. Okay. And this one, it says determine whether function f of x is continuous. And what we're going to basically look at here is wherever the domain is restricted is where it's not going to be continuous. So we're going to set the denominator equal to 0, see what makes this 0. And then we're going to exclude that from the domain, or just exclude it from the place where this function is continuous. So I'm going to take 2x minus 3, set that equal to 0. I add 3 to both sides. I have 2x is equal to 3. I divide by 2. I get x is equal to 3/2. So when x is equal to 3/2, it makes this function does not exist. Therefore, that would be a point of discontinuity because the function doesn't exist there. But for everything else, it's fine. So we can say, in terms of where the function is continuous on the interval of -infinity to 3/2, open parenthesis, union of 3/2 to positive infinity. And that would be the answer I'd be looking for in question 20. So, now, of course, I know all this stuff, so I moved through it pretty quickly when we were looking at this on a test. I hope you move through it quickly as well. It is intended, remember, to just be a review. So that when we come to class on Thursday, we're actually going to begin to learn the applications of real calculus, stuff that you'll hopefully get to use in a really good paying job in your future endeavors. I hope you found this review session to be helpful. Once again, I apologize that I forgot to give this to you in class, but I do hope that you'll find the review sections to be helpful. Please don't be afraid to email me with questions through the weekend if you have them. Thank you.